can see the team here at Novita, and we're learning about their inference technology now.
And inside each cluster, and we have many GPU nodes and many storage nodes, and all wired together by a high-speed RDMA network. And that's the very simple overview. When we talk about OpenClaw agents, the first thing that pops into my mind is KV cache, and also called prefix cache. It is a very critical piece of inference infrastructure. So in the OpenClaw agent, we can ask one question. When an agent runs dozens or even hundreds of steps, where is exactly the speed bottleneck? And the answer is not just the model itself, and it lies in how context is managed and how many prefix cache hits we can achieve. So the prefix cache hits more, and we can get more speed. In transformer autoaggressive decoding, every new token must attend to all previous tokens. If we recompute keys and values tensors at each step, especially for long context, it will be much slower and we cannot accept it. So the instance of the KV cache is simple. We can store the key and values tensors of every layer and every attention head in GPU memories and the CPU memories and even SSD storage. And so that each new token in transformer only needs to compute its Q value again and just load it back, load the key and values from our cache. Then let me walk you through what the prefix cache actually does. In this diagram, it shows a typically 3-turn agent session. It has 3 turns of requests. And in the turn 1, the user submits a task, and the agent assembles a lot of things into a single request, such like memories, tools, skills, system infos, code space, etc. And it sends it a big bundle to the server. It's a big context, such like 10,000 of context. 10,000 of tokens is a long context, and it sends it to the server. The agent then gets the result of the response. The model returns output, and the response asks for a few to calls. Here, for example, 3 to calls, and the agent goes off and executes these 3 to calls. Then the agent collects the 2 calls result and combine them together, and then append it to the end of the previous request, and then send it to the whole thing back to the server. And now here's the important. The server doesn't recompute the previous turn. You see the gray place, the gray rectangle, they are all gray. This is the cache hit. There are too many cache hits, so they don't need to recompute again and save a lot of time. Because of the previous caching, the KV tensor of everything before the new 2 calls result, they are already there, sitting in the GPU memories or sitting in my CPU memories, and we can load it back. And we just pick up them from where we left off. And what if we without previous cache? If we don't have the previous cache, we have to recompute the entire KV cache, the KV values before it. It is tens of thousands of tokens. It costs a lot, not only time and also monies. And then in the 3 turns, the server returns another output. The agent runs more 2 calls again and again, and the new tail gets computed. And finally, the server returns the result of all this, and the agent deliver it back to the user, and the user gets the final result. So next slide.
Yeah, I just want to pump in that the KV cache actually.
Next, turn left.
Yeah, you go ahead. No worries.
So we introduce our this is an open source repo, our Pega and here's the link of our repo. In most inference systems today, the life cycle of the KV cache is bounded to the inference process. For example, VRM and SGLang, they all implement the KV cache, not only on GPU, also the CPU memories, but there is one problem. There are many problems. For example, if one process is restart, the KV cache, all cache disappears. If the engine is OOM killed and all your memories is restart and the memories, the prefix cache all vanished. And also if we execute a rolling update on the Kubernetes, and then it also perform a restart, and the cache on the entire machine are reset to 0. Also, there are 8 GPUs on each machine, so there are 8 workers. There are 8 worker progress for each GPU, and they cannot share. Even though they are on the same machine, all instances may not share to each other. They reserve their own memory pool and invisible to others. So the instance and to the instance, they cannot share their cache, even they are the same. They have to copy. And here we come up with PegaFlow. PegaFlow moves KV cache management into a standalone program. It is a persistent service and written with Rust. The engine just connect it with gRPC and CUDA IPC. The cache leave outside the engine progress. So the restarts will not influence all KV cache. Multiple instances can also share the same memory pool because they are on the same machine and we handle all the CPU memory. So they can all access the same memory pool and then they can share their KV cache. And also, if model switching doesn't require the additional memory allocation because they are on the same machine. And the VRM engine or SGLang engine doesn't have to care about where a block comes because all the paths, the CPU, the SSD, the RDMA, and the NUMA affinity, all these things can be handled inside the Rust process. So the engine will not care about it. And these things all run inside the Rust progress. And it's never passing through Python. It will not import Python inside it because Python is too slow. And the next, please. Yeah, here is the 4-level. Here is the 4-level cache we definited. For level 0, it is in the GPU share memory. It's very fast, and in the level 1, it is the pin memory. And level 2, we call it from remote pin memory. It is accessed with RDMA link. And level 3 hit is like SSD, it's NVMe. We can access it with NVMe. These are 4 levels cache hit. And the next. Yeah, This diagram shows the example is an example of tensor parallel, and it uses RDMA to transfer data. This shows we make it a end-to-end NUMA-aware pipeline. So on a 4-socket here it shows 4 NUMA sockets and 8 GPUs in a machine, and another machine. The left is a machine, and the right side is another machine. It shows how we transfer the data. So on a 4-socket 8 GPU machine, the moment you have to cross a NUMA boundary, the memory latency jumps 2 to 3 times, and the bandwidth gets cut roughly half. So if we want PCIe transfer to actually hit their theoretical bandwidth, there is one hard rule. No cross-socket memory access on the data path. So we don't cross the NUMA socket. That's why in PegaFlow, NUMA aware, it runs through the entire data path from end to end. Now here at the startup, we map out the full topology, which GPU talks to which NICs, and which CPU, and the memory node. So here is this topology discover to know the whole topology of the machine and another machine. And when we allocate the second part is when we allocate the CPUs, we allocate the CPU set KV cache, we place it NUMA locally and right next to the GPU that's going to use it. And the worker threads that handle GPU load and save, we pin them as close to their target GPU as possible. And if when we need
Jimmy, are you still?
We just lost Jimmy.
Yeah, and my network just disconnect. Yeah,
Yeah,
I'm
you're
back.
okay now. You're fine now.
When we need to cross machine with the RDMA read, we pick the NICs that sits the closest memory node holding the data, and not just choose a NIC. The simple way is to choose just choose the NIC to the best way, but we also here we choose the memory node. And last, when we need to do SSD prefetch and write back, we group them with the NUMA node because SSD is bound to a memory node on the same NUMA. So we never make the mistake of pulling data into the wrong socket first, and then handing it off to the GPU. And so the principle is simple, that data should never take a detour. Every byte should travel the shortest possible path from where it lives, straight to the GPU that need it. And the next, please. Yeah, this shows intelligent routing. By default, we always ping all requests of a session to the same worker and take session A. Every turn, every 2 call, that it goes back to the same GPU. That way, the KV cache is already there, and we just keep reusing it. But the real workload is not clean. Imagine a session B has been running happily on worker 1 for a few turns, but when the next request comes in and the worker 1 is overloaded, so we have the choice. Either we wait or we fall back. Here we choose to fall back. But there's the key part. We don't throw the existing KV cache away. So the new worker don't have the KV cache already. So it have to push the KV cache directly from the original worker with RDMA network in milliseconds. It's very fast to pull all the KV cache with 8 NICs directly to the 8 GPUs we want. So the fallback worker doesn't recompute from scratch. It picks up exactly where worker 1 left off. So no recompute, no cold start, and the session just keep flowing. And so that's all. That's all about our KV cache insight. And this is an introduce of our PegaFlow repo. Welcome all developers come to contribute and use it. That's all. Thank you.
Yeah, that was amazing, and it's kind of like tough knowledge at the very beginning, but I just want to like to make it like simple words so those audience do not have any feeling about infrastructure. Uh, First of all, the catch is basically the money. If you're using any kind of a modal API, you will definitely know there's a red catch. Red catch is so much
Yeah.
cheaper. So as far as I know, we do have a very uh high let's say high number of catch limit, catch hit. So you're saving a lot of money if you're using uh our service. I don't want to be sales, but we do have this technology to optimize.
Sure.
We collab with SG Long and a lot of like teams to make every open source model, the inference better. Yeah, and the PegaFlow is definitely it's our open source project. Uh, if you're interested, we're very happy to any PRs and issues, anything, and yeah. So yeah, Andy, do
Great,
you want?
Alex.
Yeah, go ahead.
Well, I was just going to ask, is now a convenient time? I have at least one question here from Skyview 8 in the Discord stage. Requests that Jimmy address the following. As multi-agent runtimes grow, should stable operational doctrine even live inside prompt context long term? He's referring to rules, contracts, and trust boundaries. Or does it eventually migrate outward into the orchestration and runtime policy layer to reduce context pressure and drift? In your experience building this scalable architecture and supporting context across sessions that start and stop, what's your impression on that, Jimmy?
Wait, it's a long question. What's the first option?
Yeah, so today, operational doctrine, things like rules, contracts, and trust boundaries tend to live inside the prompt in the context. And so the question is, as multi-agent runtimes grow, should that even live in the context, or does it migrate, or should it migrate outward into the orchestration and runtime policy layers, which would result in reducing the context pressure and potentially drift with certain models, for example. As you know, some models are better at keeping track of rules that were given in its original prompt, and then they start to drift as you get deeper into the session. So I think this is more of a philosophical question.
From KV cache aspect, it is only one agent without multi-agent. Only one agent can do things, and also I would suggest use like in Cloud Code we use a sub agent, onboard agent, and it spawn many sub agent from scratch with only a simple context, and the sub agents do parallel. That will save a lot of context because the KV cache also even the KV cache is hit, but it also brings the pressure for in the decode phase. In the decoding phase, it have to a lot of memory bound. Yeah.
Yeah, no, I think you're right, and the practice does tend to lean towards sub-agents with restricted and relevant context, new sessions to accomplish tasks. Um, but it's an interesting thought. I mean, Skyview, I think your answer is found in what people are doing. That when you say multi-agent, I mean, I think Jimmy's right. If we're using sub-agents to execute tasks, then the functionally the operational doctrine does pass. It does get delegated to the orchestration layer in that the relevant components of it become part of the context for the sub-agents. But an insightful question, and Jimmy, I appreciate your response. Another question: We are you familiar with mooncake?
Yeah, I
Okay,
hear mooncake.
so the question is, if you could explain the difference between mooncake and KVBM.
Ah,
And forgive me because
yeah.
my
I think
understanding,
this is no it's no much difference between mooncake and KVBM and the Pegaflow. Even LM cache, they are similar. From functionally, they are similar. But we use Pegaflow is because we own it. It also is open source, but we own it. We develop it more free. We have more freedom to develop it. We don't have to submit PRs, and it also is driven with AI coding. It's all web coding. This repo is all written with AIs like Cloud Opus, like GPT. There's no human attended. We just talk it. We just talk with our agents, and it web coding with the whole project, and it do excellent work. And compared to Mooncake and KVBM, I think Mooncake is they are basically they are the same. Yeah, they use the RDMA network and the KV cache, but from the KV cache storage, the storage method is a little bit different. In Pegaflow, we prefer use the whole CPU memory of the machine. And as for Mooncake, there is a repo Mooncake Store. Mooncake Store is it suggests you to have a huge storage cluster beside the computer cluster and the high-speed RDMA network to connect these GPUs and all CPU servers and to transfer the KV cache. And this import a problem that the RDMA request is shuffled. They are shuffled, so it caused some RDMA network issues. They are, but in Pegaflow, I said we make it NUMA aware. We make it NIC aware. The data always from NUMA 0, CPU 0, memory 0, and NIC 0 to another NIC 0, GPU 0, memory 0. Yeah, they are NUMA node. They only they won't happen. It won't happen if RDMA NIC 0 transfer data to the other machines RDMA NIC 1. It is cross RDMA NIC. So it will in the cluster it will cause a cross spine network, and it increases the latency, and it will sometimes it will cause the jump. Yeah, traffic jump.
right? Excellent. Yep.
Can
Thank you
we
very
get
much.
Yeah, do we have like one more question, or we can move on?
Yeah, there was one more question. On the SSD
Okay,
tier.
yeah. Before we do that, I just want to keep this short. So This is the final question because we don't want to like occupy everyone's time. Yeah, final question. Go ahead.
Yeah, understood. Thank you.
Mhm.
The question is, does the inference engine stall when the SSD tier is brought into the loop, or is the load overlapped with compute? I'm just curious. Uh, in
Oh,
your,
I
you know,
see. It is. I think it is about the high availability. Yeah. Is if the store engine is store, it will not to influence the engine such like such like epsilon because we yes that's why we want to build it from scratch. It if the Pega server engine is stalled, it is down. The VM engine sends the request, it will not hang here. Yeah.
okay, that's great. Thank you so much, Jimmy. We appreciate your time and the knowledge that you bring to the presentation. Thank you. Back to you, Alex.
Yeah, yeah, that's yeah, I was never imagined like we do have so many like community guys they understand and they're very curious about the AI infrastructure. That's super interesting. Yeah, let's move on. And yeah, I'm going to talk about Sandbox, which is I believe some of you guys don't know what is a Sandbox, and I think this is definitely a product that designed for agents. And since we're in OpenClaw community, I think some of you guys might curious. And yeah, so I'll get started. So, like I think that there's one thing that while I was using OpenCloud or other frameworks like Codex or Cloud Code, whatever, it's like the agents they're not just the general user of traditional software because you know the general loop while you're using maybe a Discord or Slack or Windows, whatever, the workflow is fixed. Like if you're typing something, search something, you will get the response from backend and shows up on your front end. That's it. That everything's fixed. But agents are kind of like becoming the operator of different software. I mean, right now they're probably using just a few tools, a few integrations, but eventually I believe that they will be they will definitely use more, I would say, software environments. So uh that's a difference. And the environment that we provide for agents should no longer be a static, be something fixed. Like you're not only launching uh uh API or a backend. That's a general way. So Sandbox is you can consider is it's a workplace that the agent can actually operate. The agent will create this. Let's say generally we use VPS, we use Unix or Ubuntu, whatever. Uh, but you cannot actually use let the agent to create everything because that would be so much time consuming and you will face a lot of system errors, system logs. So yeah, we're thinking this is a new infrastructure for agents specifically. And yeah, as you can see, I write this simple diagram. This is a loop I believe right now every agent will follow. Once you type in some questions, your agent will exclude those search and yeah, use files, browsers, and finally we'll get the artifact. It probably could be a file or could be just a text. That's a general loop. And yeah, and yeah, back to the question that uh we use VPS or Docker right now for any kind of service, a backend service uh like they have their specific value and we're still using it. Those infrastructure are good, but it's it's the it's the cloud for human for we are actually manipulating the backend, we are fixing bugs to maintain it. It's not for agent uh for the AI can control. So we have several features. I can list a few of the features. You can consider, let's say VPS is a machine for human, and Sandbox is a machine for agent. You can customize the templates. Let's say you want a Unix with browser, with maybe other tools, maybe Python dependencies. You can customize those templates as like whatever you want. You can just go ahead and editing everything, and uh, after that environment is created, your agent can launch it at any moment. Let's say you want to exclude a Python script, you want to exclude a GS script or a search task. So once you configure everything, the agent will launch the sandbox to use that environment that you already prepared, and the timing will be very fast. You can just create right now and destroy it. Because that would be very cost efficient. You will not need to like rent a VPS, or you do the cloud. That's not efficient. And the concurrency is another feature I just want to mention, because Sandbox is generally for training. I can share a use case that Kimi actually used our Sandbox for training, for reinforcement learning training, because reinforcement learning training needs to exclude tons of tasks, like like the code task. They will receive the feedback, but you cannot do that on your own machine because you need a lot of like dependencies like Python, JavaScript, C++, whatever. But Sandbox provide everything, and you can do that training task in parallel, like thousands of parallel. Uh, so so as I just mentioned before, like right now, I believe that, or in the future, definitely, I believe that it will be the agent to manage every task. It could be very complicated because right now, let's say you're using OpenClaw to do your like daily research or whatever. It's not that complicated because you only need to use some sort of APIs or tools, and the LM can handle that. But if we're
Sure.
talking about the future, we're talking about the agent can control your system, can control everything in one shot. Not human. I have to fix. Okay, this is not right. This is you have to like do it again, fix it. If we're talking about long running and the one shot uh, outcome, I believe it will be agent to manage all of those tasks, and yeah, this is a general loops. Uh, I believe you guys probably heard of the React loop. That's the basic fundamental of agents. Every agent need the React loop, and I was thinking this is uh, our like scenario. If you're using Sandbox for one slot for long running and complicated tasks, any like I just laid several maybe coding. If I do coding, you need to like clone the repo, do test, and browser launch it. If you're doing research, you need to like use a browser to automation, and if you're doing data scientists, you maybe need to connect a lot. Uh, but all of those environments, you cannot put this on your own like one machine or a VPS, because that will be so much complicated and hard to manage. But Sandbox provides you a template, provides you a snapshot. You can reverse, you can reset to the previous session like very fast. So yeah, that's the Sandbox. I was talking a lot about what is it, and what, how the agent should actually use it. So I did this video. It's called Novita Cloud. It's not a competitor because Novita Cloud is we just wrapped OpenClaw. Uh, OpenClaw as the underlying framework, and we just wrap it. And I believe some of you guys are probably okay. Let me make the audio a little bit less. Okay, it's basically a one. If you installed our packages, I think I can zoom in, make it bigger. Oh, sorry. Yeah, you can just use one command to launch your OpenClaw. We wrap it using our sandbox, so everything is super easy. You don't have to like config everything. Yeah, I just put it. Okay. Oh, why I click that again? Sorry. Yeah, let me jump into it.
So, what are the default configurations when it comes up? So it's set up to use Novita Inference.
Yeah, you can
what
actually.
models is it using?
First of all, for the convenience, the default is Novita Inference because you have the key already. You have the Novita key already. So as long as you launch it, you can use it right now. You don't have to like configure everything, but you can still have options to like select other providers. So yeah, as you can see, you can get into the dashboard right away. Basically, let me replay this. Basically, what you did one thing is use the launch command. As you can see, use the launch command. Here we go. Oh, why it's so bad?
Yeah.
Okay, that's it. And yeah, I'm not trying to tell you guys like we should use it right now or whatever, because I believe there are so many similar products. You can do a very similar way, but I'm just trying to present the insight, because Novita Cloud is just a wrapper of Sandbox. You can wrap anything, like you can wrap Cloud Code or Codex or Open Code, whatever. Yeah. So
Beautiful.
yeah. So this is a very interesting. Another very interesting feature is auto pass. Because I believe everyone cares about the price, cares about the money. So if you're using VPS, you have to like rent it for at least I don't know. You can use on demand, or you can use like 1 month or one year, whatever. But the point is, we have this auto pause feature, which is basically if you launch Novita Cloud and it's not actually working. I believe everyone have that moment. Like you're probably busy, you're not actually using your OpenClaw. So this feature is super interesting, and I like it. So once you launch your Novita, your OpenClaw while this sandbox, if it's not working, you don't have some sort of core jobs, or you don't have anything active, it will be paused, and you don't have to cost anything because it's on demand, it's auto pause. It's a super interesting idea, and that would be very quick. So as you can see,
is the billing increment per minute or per second, or
I cannot be that specific, but I believe it's minutes. It's minutes. You can find the very details on our website.
Sure.
Yeah, but I just think this. I just want to share. This is a very super funny idea. Because auto pause is it's kind of some people would definitely have this requirement, and as you can see, we basically we can detect the backend activities to kind of pause it. That's not a very tough technologies, but it's interesting. Yeah. So
yes.
Yeah. So final thing is I want to share is a little bit about our I would say use case or achievements, and yeah. Yeah, that's it. I'm gonna skip that. Yeah, so the final topic. Yeah, before we go to the final topic, do you have like any question you want me to get it?
No, this is excellent.
Okay.
It's very helpful, and it's innovative. We're excited to see it. And in the same way that Peter had the difficulty of describing
Mhm.
exactly what OpenClaw did at the time, it was Claudebot, and
Mhm.
he would tell people about it, and they'd go, "Oh," and they didn't really get it. And it wasn't until he started showing people what he could do with it that it
Yeah.
became innovative. Well, I'm sorry, it was innovative to start with, but before people could understand it, the examples that you've given have been very helpful insofar as helping us understand what this technology can be used for.
Mhm.
The idea that we could take an agent that used to spawn 2 or 3 sub agents and it was hardware constrained on a Mac Mini, properly configured, it could spawn 5,000 sub agents
Right.
and not be hardware constrained on any of them.
Right.
It's very exciting.
Right. That's why we're just believe that Sandbox is just designed for agent. It's not for human, and we believe in the
Yeah,
future. The future is for agent, and yeah.
that's that's your new marketing campaign. This is
Mhm.
this is cloud for agents. I like it.
Yeah, yeah. So yeah, I'll move on, and the final thing I want to share. I think this is kind of a common sense right now. Like every company is releasing their own CLI, because we build any company, as long as it's related to AI, uh, they know everything is built for agent. Like we don't really install anything or try to like find out the exactly API is. So yeah, CLI is we have this CLI. I believe some of the competitors they have this as well. But the interesting part is, first of all, we have lots of modal APIs, not just LM. We have image, video, and embedding, voice, and the GPU as well. If you want your agent to actually control the GPU resource, like if you're training, you're doing some training tasks, and you can just let the agent now launch a H100 GPU for any sort of a task and do it right now. You can
Oh
use
wow.
CLI. Yeah, that's super interesting. And yeah, we have a model API. You can let the OpenClaw to install this CLI to like OpenClaw now generate uh, videos. I know you guys have a built-in providers, but the convenient part is you only need to configure one API key to access all of those models. So I believe that's probably a feature for us, and GPU I just talked, and Sandbox as well. One CLI which basically contains every features that we have, and all you need to do is one API key, and that's it. You can access most of the resource if you want. So yeah, oh, I listed is here. As you can see, billing as well. You can need the agent to query what is your consumer status, what is your credits right
Sure.
now. So yeah, I think that's pretty much about my content. And yeah, final part is is a giveaway. I believe that the best thing is we want the open cloud community, like those developers, to actually use it. So I'm going to post a form, a Google form in the Discord channel, like a little bit later. So anyone, you can just choose choose the open cloud option, and you can get free credits, a few free credits to try everything. Yeah, yeah, that's pretty
Great, and
much.
I'll
Mhm,
make sure that link gets posted in
mhm,
the Claw Tributor channel and the developers voice channel side chat when you're prepared with it.
mhm.
It's a generous gift to the community, and we appreciate it.
Yeah,
Thank you,
sure.
everyone.
We definitely we like OpenClaw, uh and we want to like maybe more events, like more hackathon or whatever. Because yeah, I never imagined at the very first part it would be boring. I know that AI infrastructures, people just want to like what are you talking about, but I never imagined that the community guys, they know, and they're curious, and know those technology. That's very interesting. Yeah.